We did discuss this circuit for improving the power factor. Let us try to simulate this circuit now and try to get some insight onto the waveforms and see if the waveforms that we get in the simulation are matching with what we have discussed. So let me create another folder and I'll call this one as rectifier power factor EF. So I will go into this single phase rectifier, again do the same thing, pick the schematic and the symbol and models. I'll copy that. I'll go into rectifier power factor and place it there. I will open the rectifier schematic. You will see that the symbols are not recognized. No problem. We will close it. The rectifier project file has been created. Double click on that. Go to the symbol library editor and then here I will add symbol library my components. I will open that into the project. Then yes, we have this my component symbol library and then we can close that. So now when I double click on the rectifier schematic, we have the circuit. So this circuit we have. Let us modify the circuit to to get this particular circuit configuration, and then let us implement that in ngSpice. Let me edit the title. We will call this as passive power factor improvement. So this is our modified title, and now let us do the editing of this circuit. So now let me include one more capacitor. I'll go into the components, place one more capacitor, C, I'll have that, and then I will need 3 more diodes. So I will pick 3 more diodes. So like this, I have 3 diodes. Now using these components, let us place it around to obtain the circuit that we discussed. So let me make some space and do that. So I am trying to place these components at appropriate locations so that we'll have that circuit like we discussed. So I am moving around the components, as you will see here, in this fashion, such that it will look like the circuit that we discussed for passive power factor improvement. So more or less it is there. Now let me draw the wires, connecting wires. So by now you must be familiar with connecting these wires, placing the components, libraries. So making the schematic in KiCad, you should by now be very familiar. So in this way you make this circuit connections. Now the circuit connections are complete. Now let us do some renaming of the references. So you have D1, D2, D3, D4. I will continue with D5, D6 and D7. Then the capacitor C1 and C2. So let me call this C2, and I will give the same value of 1000 microfarads for this capacitor also, C2. Right, all else are fine, they remain the same. So you have the circuit. Now let me move this label to this point. This is the output. Let me connect with a wire. This label is now connected as the output. We could probably label this intermediate nodes. I'll call this as X. We'll place it here, and I will pick one more, and Y. I'll call this as Y, and let us rotate in this fashion and keep it. Now we will make the connection with the wires. So X is connected here, Y node is labeled in this fashion. So you also have the nodes labeled. So in the control commands here, VAB, let us see Vx and Vy also. So we can have Vx and Vy as two voltage waveforms that we would want to see, apart from V0 and the current, the input current. So that's it. You have all the items covered, and we can save this. You can go to Tools, Generate Netlist, Spice Netlist, and generate that. So you can save it as a .cir file and go to the folder. Now in the folder you see rectifier.cir has been generated. Double click on that. So you see the entire schematic. So this is basically the full bridge rectifier part, and you see these diodes are the passive power factor improvement part, and you have C1 and C2 coming in here, C1 and C2. And let us see the voltages Vx, Vy, and see if they are as per the discussion that we did during the theory classes. So we will implement this, we will simulate this. Let us open a command window. Let me go to the folder where this exists, PF. So we are in the rectifier PF folder. See that this is the same path of what we have. So rectifier.cir is what we need to simulate. ngSpice rectifier.cir, and we simulate that. So you can see that, you can expand this, yeah. So you can see that this yellow colored waveform is V0 here with a ripple almost 50%, as we have discussed, and the waveform profile is like we have discussed. Then the red colored waveform Vx and then Vy. So I will leave it to you to get as much insight as possible. You can probe the voltages and the currents through any branch and try to understand what we have discussed.